Welcome to engineering graphics. So today's topic is cycloidal curve. So cycloidal curve, first we have to discuss the definition, then we have to move the problem. Direct we have to go to problem. So cycloidal curve. Cycloidal curve is nothing but a cycloidal curve generated point A P on the circumference of a circle, on a circumference of a circle, which moves along a straight line, that is nothing but PQ. The name of straight line is PQ. Without slipping, it travels one revolution. So that is called a cycloidal curve. So in that PQ we have a straight line following the formula is pi d. Pi is nothing but 22/7 and d is nothing but rolling circle diameter. It is given to the question. So we have to see the consider the a cycloid is a curve generated by point P on the circumference of a circle, which moves along a straight line, without slipping. It travels one revolution. That is called a cycloid curve. And this one is rolling circle. This one is directing circle, and it moves along a straight line, that is P and Q. The formula is pi d. Pi is nothing but 22/7. D is nothing but rolling circle diameter, which is given into the question. So this is the cycloidal curve definition. So directly we have to go to the question. So this is the question. Draw a cycloid of a circle of diameter 50 mm for one revolution. Also draw a tangent and normal to the curve at a point 35 mm above the baseline. So first of all we have to discuss with the rough. So draw a cycloidal curve. So cycloidal curve definition: a P point is circumference of a circle. Without slipping, it travels one revolution. We call as PQ, and the formula is PD, and it is a cycloidal curve. This is the rolling circle, and this one is directing circle. This is the basic definition of a cycloidal curve. So first, given the question, draw a cycloid of a circle of diameter. So given in the diameter D is equal to 50 mm for one revolution. We know that is the one revolution of a cycloid of circle. Also draw a tangent and normal to the point 35 mm above the cycloid. So pi d. Here the formula is 22/7 into d means 50. So 22/7 into 50. So calculate 22/7. It approx 156.2. So near we have to do 157 mm. So nearby 157 mm. So in clearly we discuss now with the instruments. So this is the solution. Solution is nothing but cycloid of a circle of a diameter 50 mm, and it is one revolution. We know that. Why? Because we already discussed in the basics of the cycloidal. So pi d is nothing but the formula. We have to calculate the straight line. So straight line we have to calculate the formula pi d on a cycloidal curve. So pi is nothing but 22/7 into diameter already given in the question. So we have to substitute here 22/7 into 50 mm equal to 157 mm. So now we have to construct a with instruments of cycloid. Take the scale of measurement of cycloidal circle of diameter is 50 mm. So say take the measurement of 2.5 mm radius. Take the compass and take the scale, take the measurement, and then draw a circle of diameter is 50 mm. Yes, this is the 25 mm, and this one is the point C naught, that is the center of the circle. Draw a horizontal line and vertical line, it passing through center line C, that is circle of the center. Okay, this is the C naught, And now we are considering already pi d is equal to 22 by 7, 50, that is 157. So we have to consider this is the P point, and from P to Q it is a 157, means 15.7. The distance is 15.7. Take the scale from P to consider 15.7 and 0, this is the 15, and 15 plus 5, 15.567. Put point of 15.7. Draw a straight line, and this is the P point and this one is Q point. Now consider 157 mm. Now you have to divide circle into 12 equal parts. Already 1, 2, 3, 4 already divided into 4 equal parts. Now divided into circle into 12 equal parts. So from the geometric construction method, cut the arc on the upside, downside. Similarly, change the center, same radius, cut the arc left, right. Similarly, same radius, cut the arc left, right. Similarly, change the centers, left and right. Then you got a 12 equal points. Then join the points from C0 from to there. Similarly, you have to consider the circle into 12 equal parts. Join the same centers with the 12 centers. Yes, give the names of anti-clockwise direction. Why? Because this is a rolling circle on the circumference. So after that you have to roll the one by one step. That's why you have to go clockwise, anti-clockwise direction. You have to give the names: 1 prime, 2 prime, 3 prime, 4 prime, 5 prime, 6 prime, 7 prime, 8 prime, 9 prime, 10 prime, 11, and P point and 12 prime point both are same. Now draw a center of the line with the same distance of 157. 157 of the line. Draw a straight line. Draw a rectangle box of PQ. Next you have to divide the circle divided into 12 equal parts. Same, you have to divide the P and Q, the straight line, divided into 12 equal parts. Now you are consider line divided into number of equal method from geometric construction, or else you have to divide 157 by 12, then divided into 1 equal part. You have to divide PQ equal parts. Circle divided into 12 equal parts. Again you have to divide the PQ line also divided into 12 equal parts. It is equally divided from, if you have to suppose calculate from geometric construction, line divided into number of equal parts. Same method you can do here. For PQ line, divide some angle of less than 45 degrees, then divide some 12 arcs, then draw a join last arc on a PQ point. Consider like that only, or else you have to divide directly with PQ with the equal 157, means approx 157 mm. So it is approx 1 divisions are around 1.3, nearby 1.3. Take the distance of 1.3, 1.3, like that only you have to divide the 12 equal parts. So we have to divide PQ equal to 12 equal parts, and circle also divided into 12 equal parts. Now take the scale and join the rectangle box of from 6 prime to 15.567. Join a rectangle box with the same distance. Similarly, you have to join the same 1 prime and 10 prime. Join the straight line with the same distance 157. Like that only 10 prime you have to travel from 1 prime with the rectangle box. Similarly, we have to travel 9 prime, 3 prime up to 15. Next, consider here 8 prime and 4 prime. Join the 7 prime and 5 prime. Then draw a rectangle box of the distance is same 157 mm. Now, you have to highlight the center point C0. This is the center of the circle. Then highlight the center of the circle with dark, some little bit dark. So I am using here blue pen, blue color. Consider little bit dark. Then you have to join the vertical lines. Already you are divided the PQ lines 12 equal parts. Give the name of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 point and Q point are same. Here the P point and Q 12 prime point are same. Then join the center of the line. Join the center of the line with the vertical lines 1 C0, next 2, similarly C2, similarly C3, C3, similarly 4, C4, 5, C5, 6, C6, C7, C7. Just you have to draw a horizontal lines with the joining of center lines. Give the names of 9, C9, 10, C10, 11, C11, 11 and 12 and C12. Give the name of. Draw a circle with the radius of 50 mm. And next draw a P and Q point, that the straight line circumference of a circle of 157 mm, that is pi d is equal to 157 mm. Then from P point, the circle you have to divide 12 equal parts. Give the name of anti-clockwise direction, and the straight lines PQ you have to divide the 12 equal parts with the consider of 157 approx 1.3 and give the name C0 to C1, similarly C12 and P to 1 to 12. This is the base. Now next step is the centers will be changed. The radius is fixed, that is R is equal to 25. R is equal to 25 mm and centers will be changed from C1 to C12. Okay. So consider as a draw an arc with the center C1 and radius is 25 mm radius. Take a 25 mm radius to intersect the horizontal line through point 1, that is point P1. One line. Where is the one line? We have to consider C1 as a center and take the radius of R is equal to 25 mm. Cut the horizontal line of 1, travel the 1. That is point P1. Similarly, same center C2, take the radius of R is equal to 25 mm radius. Cut the horizontal line, second line. Where is the second line? From bottom to second line. That is the second line, that is C2. And next, change the center C3, radius is 25 mm. Cut the horizontal line, third line. Where is the third line? This is the third line. Cut the arc. Similarly, C4 as a center, same radius. Cut the fourth line. Where is the fourth line? This is the fourth line. Cut the arc. C5 as a radius. C5 as a radius and take the radius 25 mm and horizontal line, fifth one is a horizontal line. Cut the arc on a fifth line. Similarly, C6 as a radius, okay, C6 as a center, C6 as a center and 25 mm as a radius. Cut the horizontal line on a sixth horizontal line. Cut the sixth horizontal line. And C7 as a radius. C7 as a radius. Similarly, C7 as a radius and 25 mm as a radius, C7 as a center. Cut the arc on a seventh line. Similarly, C8 as a center and 25 mm radius. Cut the eighth line. Where is the eighth line? This is the eighth line. And C9 as a center. C9 as a center, 25 mm as a radius, ninth line. Where is the ninth line? This is the ninth line. Cut the arc. And similarly, C10 as a center. Where is the 10th line? This is the 10th line. Cut the arc on a 10th horizontal line. Similarly, C11 as a center. Where is the 11th line? This is the 11th line. Cut the arc on a horizontal line of 11th horizontal line. Next, C12 as a center, same radius, that is 25 mm radius. Cut the arc on a PQ line and 12th line. PQ line and 12th line. Then consider as a points of P1 point, and next this is the P2 point, and this is the P3 point, P4, P5, P6. P6 as like that only umbrella type. P7, P8, P9, P10, P11 and P12. That is the arcs. And just you have to simply join with the P1 to P12 with the free hand of a cycloidal curve. Cycloid, just join the with the free hand of with the points to join from P1 to P12. Then you got a beautiful cycloidal curve. This is the cycloidal curve. Okay. So first point is draw a cycloidal curve of a diameter is 50 mm. Draw a circle, then divided into 12 equal parts. Then you have to consider from P to Q is a straight line, that is a 159. That is a formula is there, that is pi d. You have to consider pi d formula, then calculate P and Q equals straight line. Then join a PQ point with a rectangle box of from P to 6th point, join a rectangle box. Then consider a 1 prime, 11 prime, join a horizontal lines, 2 prime, 10 prime and 9 prime, 3 prime, 8 prime, 4 prime, join with the same 7 point and 5th point, join a rectangle box. Then you got a rectangle box of a PQ to 6 prime. Okay, then consider again into P to Q divided into 12 equal parts, 1 to 12, circle into divided into 12 equal parts, 1 prime to 12. P point and 12 are both are same. Here Q point and 12 point are both are same. Now consider a center line with a dark line, C0 to C12. Give the vertical lines, give the names of C0 to C12. Then consider radius. Radius is fixed for 25 mm. Centers will be changed from C1 to C12. So like that only. First one is C1 as a center. Radius is 25 mm. Cut the horizontal line of a first line. Cut the line. Next C2 as a center. Horizontal line of second line. Cut the arc of radius how much? 25 mm. Similarly have to same like that only. So C12 as a center. C12 as a center. And 25 mm as a radius. Cut the 12th line. Where is the 12th line? That is a horizontal line of PQ and straight line. So similarly have to give the points of arcs P1 to P2, P3, P4, P5, P6, P7, P8, P9, P10, P11 and P12. So similarly have to draw a, with the help of free hand, draw join A, with the help of join A, P1 to P12, P3, P4 and P12. Then you got a beautiful cycloidal curve.